Hello students, welcome back. Previously we went through absolute value equation. Absolute value is obtained by putting extra negative when inside is negative so that outcome is always positive. And thus we have two types of equations. Straight up equation when positive, negative equation when inside is negative. So one absolute value equation creates two linear equations, positive, negative. Here I use blue and red, and sometimes both are solutions, as in this case. So we have two solutions. Sometimes only one of them is solution. And then, of course, there must be some cases there none of them is a solution. Now let's go to absolute value inequality. We can consider two types of absolute value inequality. In this course, we're going to do only the first type, the blue type. Absolute value is less than something, then we end up with a double inequality between negative q and positive q. Now, if the absolute value is greater than that, then we get the negation of that, so we have two separate intervals. But I don't think we're going to do these at this level. After all, this is business algebra, so we're not going to do everything that people do in STEM algebra. Okay, here's an example. You're going to need a little bit bigger font. We have fraction there. So, okay. So this equation, excuse me, let me prepare first. Okay. This kind of absolute value equation is the same as this double inequality. Negative of outside, positive outside. We have strict inequalities, so all those are strict. And solving this, hey, we went through those before. We move the denominator first, multiply by 5, so negative 35 to minus 3x, positive 35. And then flip over to negative 37, negative 3x, 33, divide by negative 3. So what do we have? 33 over negative 3, that's negative 11. And then this one here, no choice, 37 over 3. I'm forgetting something. Okay, all right. So we can express like this as an interval expression. Smaller number, comma, bigger number. Both are strict inequalities, so we need parentheses. What did I do over here? Yeah, same thing. What if we have semi-inequality? In that case, both are less than or equal, so we're going to get a bracket. Stop the playback and try on your own. See what you get. So here we have 1, so negative 1, positive 1. Oops. Semi-inequality, so it has to stay a semi-inequality, both cases. So half open, half closed, those kind of things can take place in double inequalities in general, like these, but you cannot have those kind of things for absolute value inequalities. Everything was generated from this same less than or equal to, so everything must be less than or equal. Divide away, multiply away this denominator. So negative 9, 2x plus 1, positive 9. Subtract away this 1, so negative 10, 2x, 8. Divide by 2, negative 5. I guess that's it. So we have interval negative 5, positive 4. Yeah, there you go. Is that what I got here? Yes. Okay, that completes the absolute value inequality. Most of the time, equations are easier than inequalities, but this was one of those exceptions, right? Well, that's because we restricted ourselves to easier case. If you have absolute value greater than something, then things are going to get more complicated. Okay, we have enough time, so let's go to section 5 application just a little bit. We're not going to deal with a lot of applications here because we're going to have a little bit better tool, actually much better tool in lesson 5. So that's where we're going to focus upon the applications. But still, we can do a little bit. Remember this problem. Suppose that the relation, let me see. Okay, all right, that's a little bit easier to read. Suppose that the relationship between the firm's profit P and the number of sales X is as follows, and 5X minus 4P equals to 1,200. Do you remember this? We went through this right here, this one. And then you can solve for X, and then you can solve for P. We did both of those. Solving for X, solving for P, remember? Okay, A, how many units of item must be sold to make the profit of $150? So P is 150. So plug in P is 150. That's 150. And then we have an equation. So 5x minus 600 is 1200, so you can solve 360. That's one way to solve. Another is to solve for x symbolically. And then plug in P equals 150 in the end. Either way, we get the same thing. Now, if you have just one number to plug in, the first solution is going to be easier. Just work out this equation with numerical values. But if you have to plug in not just 150, but many, many different p-values, say 6 of them, and then if you do that, you have to solve an equation 6 times. If you do it this way, then you solve it symbolically just once, and then plug in 6 different values for p. So depending upon the circumstance, solving for a variable with respect to another characters can be a little bit more effective. But in this particular case, just one number to plug in, so solution 1 was more effective. Same here. Profit P, find profit P when x value is 240. Solution 1 is plugging 240 in place of x and solving the equation numerically. So this is just numerical equation. And then we end up with P equals to 0. Okay, all right. So 0 profit if you sell too many items. Now for solution 2, that's a little bit different story. solve symbolically p equals 5/4 x minus 300 if you do it like that. And then you can plug in x equal to 240 in this case. Now, if you have 5, 6, 7, 8, 9, 10, or maybe 100 different p-values to plug in that case, it's going to be better to solve symbolically and then plug in those 100 different values for this x, rather than solving the equation 100 times. But if you have just one number, in this case, it's going to be easier to do it with solution 1. Still, I have no idea why our textbook author selected this problem as an application. Just stupid. Now the second problem makes a bit more sense. This is something we already did previous week. But then again, we're going to deal with a lot better tool in week 5. So let's not overemphasize section 5. And then we'll say we are done with lesson 2. All right. See you next week in lesson 3.